Hey, what's up guys? My name is Cherno. Welcome back to my game engine series. Feels so good to say that. It's been so long since the last episode. I am now married, so finally we can get back to this game engine. Am I right? That's probably what all of you have been thinking. I mean, I'm very happy with the wedding. Everything went really well and all of that. Can't say that the game engine was on my mind, but it is now. So we're gonna get right back into it and we're finally gonna start on rendering because I feel like rendering was a huge kind of thing that I was waiting to do and didn't have time, but now I've kind of got a lot more time, so we're going to just jump right on into this and begin our journey into creating a renderer for Hazel. First of all, I just want to give a huge thank you to all the Patreon supporters that actually made this series possible. You can head on over to patreon.com/the Cherno and help support the series there. You'll get stuff like access to the source code that I've already written for Hazel, which is kind of my own private development branch version of Hazel. It's a lot more advanced than what you see here, and like very many videos essentially ahead. And you'll also get access to like private channels where you can talk to me and do a whole bunch of other stuff. So huge thank you as always to those people who are generous enough to support this series. Okay, so rendering. The first thing that we need for our renderer, and we kind of went over the rendering architecture of Hazel. If you guys haven't seen that video, definitely check that out. Last episode as well was the whole kind of making Hazel into a static library and cleaning everything up. I'm really happy that we did all that, because now, I mean, this compiles with 0 warnings. Everything is just ready to go. It's a static library. It's all kind of just ready for us to continue development. And that's a really good state to kind of be in for something as big as the renderer. And I mean, as much as I'd like to just write a renderer from start to finish, there's obviously going to be auxiliary stuff that we kind of do. Like will probably at some point I'd want to write some ImGUI kind of widgets, or just like maybe even use this kind of docking library that we have in ImGUI to create somewhat of like an editor or an interface. It's not going to be like, bang, let's just go from nothing to having like a full kind of PBR deferred renderer that does everything and post-processing and everything, just kind of without taking a break. There are going to be bits in which I'm like, okay, well now let's focus on something else. So I just don't want you guys to be too disappointed if that happens. I'm going to write this renderer as I would write a renderer. There's not going to be any kind of like modification that I'm doing just because this is a video series. I'm just going to kind of do it my way. And hopefully that's kind of something that you guys will be into, but we'll see. Obviously, I'm always open to feedback, and the comment section is really important to me. I mean, I used to just like look at diffs and copy the code that I wrote earlier, but clearly you guys didn't like that, so I now write all the code live to the point where I actually don't even know what code I'm going to write today, but hopefully it's going to be good. Anyway, enough chit chat. Let's talk about what we're actually doing today. So the first thing that we need for a renderer is a context. We need a rendering context. Now we have we rendered a triangle in OpenGL in Hazel before? I don't actually know, because I don't remember. But we need a rendering context. Again, that rendering architecture video is really useful, and that will kind of cover, the reason I keep talking about it is because it kind of covers the fact that we need a rendering API, like a renderer and then a rendering API, right? This is part of the rendering API. This is something that's going to be different for each renderer that we actually use, or for each API that we use. So by API, I mean things like OpenGL, DirectX, Vulkan, that kind of stuff, right? We need a way to create a context for that API. So in OpenGL, it's really simple. And in fact, GLFW handles pretty much all of it for us. It's super simple. For Vulkan, it's a lot more complicated, like everything else is, right? We need to create, apart from like doing things like picking the logical and physical device, which means just picking which GPU to use and then creating like a kind of a Vulkan side device for it and all of that stuff. We also need to create things like the swap chain. This is a lot more simple because we're dealing with OpenGL to begin with. Don't worry, we will get to Vulkan. Hazel will support Vulkan at some point in the future, and we'll kind of cross that bridge when we get there. But for now, in OpenGL, it's dead simple. So I'm not going to create a billion classes right now or a billion files that kind of do all of these different abstracted things until we actually need to. But I will create an OpenGL context kind of file, which will contain everything that OpenGL needs to actually render things. And we're going to kind of decide how we abstract that away from basically the window class, in which it kind of lives there right now. Because obviously we have written the kind of context creation and also the swap chain code. What else is there to say, really? I just want to jump into Hazel right now and take a look at if we have a triangle, if we can get a triangle on the screen, and then we'll start actually kind of stripping that code out and creating our context class. And we'll kind of talk about why we're doing that and how it's going to work as well. So let's just jump on over into the code and see what we have. All right, so this is the window class. This is the Windows window class to be more specific. So inside our initialization code, we kind of have these three lines, right? We have this make context current. If we look at what that actually does, you'll see that basically this window has a context class, right? This is very similar to what we're actually doing now. We've got a window class that's kind of our, Windows window in this case. But then what we don't have and what we need and what the purpose of this episode is to create this context class. And this context class is going to basically contain context specific, so graphics kind of rendering context specific. So in other words, OpenGL specific in this sense, code, right? So this window context make current, again, is something that GLFW will do based on the context that you're using. Could be OpenGL. GLFW also supports Vulkan. That's essentially what that will do. It will just kind of take the window handle and then set that window handle as the rendering target or context for the rendering API that we're actually using. And GLFW will kind of do that for us so that we don't actually have to touch like Windows specific code to set up an OpenGL kind of context. Same with Vulkan as well. Instead of kind of retrieving certain pointers from the Vulkan DLLs to set this up for Windows, and that's done via essentially KHR extensions, Chronos extensions. Instead of doing all that stuff, it kind of just does it for us, which is great. For Vulkan, we probably will use GLFW as well, although in my kind of own personal Vulkan projects, I've always done everything manually. So we'll see. Again, as I said, we'll cross that bridge when we get there. We're doing OpenGL for now because it's the most simple API to use. And then there's swap buffers, right? Which is the swap chain I'm talking about. Again, super simple. It does it for us, right? So we essentially need to call this line of code and this line of code, but I don't want to do it from the window. I want to do it from the actual context class. And you might be like, why? Why are we doing that if GLFW already abstracts stuff for us? Why are we adding another layer of abstraction? The reason is, this is definitely not all we want to support. GLFW supports OpenGL and Vulkan, which is fantastic. But what we actually need is also support for DirectX and Metal, right? Possibly even other APIs if we, go onto the PS4 or anything. I want to kind of future-proof this, basically, is what I'm saying. But DirectX will 100% be supported. Metal as well, almost definitely, but way further down in the future. So because of that, we can't just have GLFW make context current here, right? Because this implies that every Windows window that we ever make will initialize a GLFW context. GLFW context means that it's going to be either OpenGL or Vulkan. So how on earth from this code do we say we want a DirectX context? We can't, right? And that's a problem, which is why this needs to be abstracted out into a class that we're going to call OpenGL context, essentially. And then this, of course, also loads OpenGL kind of extensions, right? Again, not something that needs to be done for DirectX or even for Vulkan. So this stuff is really kind of API specific, and that's kind of the goal. It's going to be to kind of move that stuff out and create it, kind of put it into its own class, which again, the implementation of that class will be dependent on which API we actually pick. And also, APIs are going to be picked at runtime as well, right? So at runtime, we'll be able to decide on Windows, for example, if we want OpenGL, Vulkan, or DirectX, since that platform supports all three. And then if we scroll down a bit, and on update, we've got poll events, which is great, but then we've got swap buffers. Again, this is kind of the window on update function. This is when we want to refresh our window. So that's not something that really kind of, this GLFW swap buffers is not something that we really do for, DirectX or Metal or whatever we're using. It's not going to be Metal, right? Because this is Windows window. But anyway, for DirectX, not something we want. It'll be completely different, right? So because of that, we can't just do GLFW swap buffers. We need to essentially do something like mcontext, .swap buffers. Now this might even be something like, if we want it to really be cool, it might even be context, get swap chain, and then, flush, or I don't know, it might be, the API will probably change over time, especially if we decide to implement Vulkan as like kind of not a through GLFW kind of route, because that does simplify things, but we'll see. In that case, we might have to do stuff like this essentially, and we might have to set up abstractions for all the APIs to be able to do that. But for now, I think that's pretty good. Context, swap buffers kind of makes sense, and it's clearly going to touch the swap chain. So I'm pretty happy with this kind of API for now. So we'll kind of just leave that there, just so that we can fill in the blanks in a minute. Here as well, pretty simple. could definitely be something like context equals new OpenGL context, and that will kind of just create the context there. I don't actually want to do that though. I'm actually going to, the context is probably going to be a stack variable that just gets initialized automatically and may perform some checks to make sure it's actually valid. I'm just thinking about how I want to do this. No, having a stack variable probably isn't the best thing to do, since it will actually need to be kind of polymorphic, in the sense that like we might have a derived class that is dependent on the API that we actually choose. There's also going to have to be some kind of context selection. So I think that ultimately speaking, context will most likely be just a pointer, in which case we'll leave an arrow here for now. Context might even be something that's static. Yeah, the ownership of context is something that we haven't really thought about. That's kind of important because, you know, should the window essentially own the context? That's one way of doing it. If we look at window, I usually like doing that, having the window own the context. I think I've done that in pretty much everything I've ever written. But I still do like the context to be something that is static, because it's not something that, you know, a rendering context, you almost always have one of them, at least per window, right? You're not going to have multiple rendering contexts. Just trying to think. I mean, there are advanced things you could do. There's always things that you can do, right? I just want to make that clear. In fact, I'll just pop back from the screen to the camera to even say this. There's always things that you can do that you might want to kind of modify this design for. I want to kind of make that explicit as well. Designs that we decide on right now are not going to be final. They're going to be liable to change, just like anything ever. One thing I can think of is some scenarios is you might want to do something like have a window, and then inside that window have like kind of a split view maybe, and then half of it's being rendered using DirectX, half of it's being rendered using Vulkan. That's something that people have done before. In fact, EA's kind of Halcyon, like EA's, the seed kind of research engine that EA has. There's a public kind of PowerPoint presentation that I can link in the comment section below if people are interested, or in the description. That's something that, for example, does DirectX and Vulkan rendering at the same time in the same kind of frame, like in the same window side by side, so that they can, as they develop, you know, Vulkan, for example, they can kind of compare it easily to the DirectX 12 renderer and see if there are any kind of discrepancies between the two rendering kind of visuals, essentially. So there are always things that you can do, like that might break this design, but for what we're doing right now, at least, I feel like having a static context is pretty reasonable. What you're going to do in Hazel is you're going to kind of open up a window, you're going to create a rendering context for it, say DirectX, and that's it. You really don't have any reason to change. If you do have a reason to change, you're going to basically recreate the whole thing, right? So you're going to be like, okay, I want to tear down my window, then I want to create a new window which might use Vulkan or something like that, right? And maybe in that sense, you could even have two windows open that would use that. But again, just to keep things simple for now, because we could spend hours discussing this. In fact, we've already been discussing this a lot. But I think that what we really should do and could do for now is just basically keep it simple and say that we have a window, we have a rendering context. That's it. We have one rendering context. That's what you use to render in Hazel. It's one context, done. Okay, let's get back into it. Okay, so that's what I'll kind of do for now, I think. And then we can also create kind of a static interface to that context so that we can access it from anywhere in the future. But what I will do for now is inside Windows window, I will probably create essentially some kind of rendering context. So we'll say rendering context. I'm not even sure what to call this, because probably a graphics context. We'll make it a pointer, M context, right? And then this is something that return Windows window init. You know, we might want to say at this point in time, based on a property, even you could define it, but what I'm going to do is just say that the rendering context right now is going to be a new OpenGL context, right? Graphics context. OpenGL. We can just call it OpenGL context because it's obviously going to be graphics. I'll put that under the core info. It doesn't really matter what this line of code is going to be, because I'm not going to do anything in this initialization. Like in this constructor, we're not going to do anything, so it doesn't matter if it's really before or after GLFW. We might want to put it after, but not really that important, because over here is where it's actually going to be initialized. And that's where we're going to do the following code, right? So this now kind of belongs inside that line of code, right? And then we're going to do all that, and then obviously we're going to do the swap buffers thing, which is going to be inside context right over here. Okay, so now we're pretty much done. Let's go ahead and create that. So what I want to do is inside, well, let's just make sure we're in show all files. Yep. We don't actually have anything to do with the rendering, so I'll add a new folder called renderer. And then inside there, I'm going to make a header file called graphics context.h. We're going to obviously put this into the Hazel namespace. Graphics context. And then inside OpenGL, I'm also going to create a new item and a header file. It's going to be called OpenGL context. And then we're going to also create a C++ file, which is called OpenGL context. And that's going to include our PCH and the OpenGL context file, namespace Hazel. We'll just copy that. Put it into the header file, class OpenGL context, public graphics context. Maybe we should have called it rendering context because it's the renderer. Anyway, I really could not care less about names right now. We might change them depending on my kind of mood, but we'll just say this is going to be in Hazel renderer graphics context. Cool. So that's our context essentially. But we probably could just keep it called. We could just call it context because it's obviously inside the renderer. But because we're not using namespaces like renderer, I thought it'd make more sense to actually call it graphics context. This is going to be again just a normal kind of interface, which will have certain things like init and also probably swap buffers. Very, very bland for now. I'll make these things pure virtual, right? Very bland for now, very simple. We're going to keep it as simple as we need to because, well, first of all, rendering is going to get complicated enough. And I'm going to try my best throughout this series to keep it as simple as possible, right? But also because OpenGL really is that simple for now, especially with GLFW. So this obviously is going to overwrite this stuff. Now here's the thing. Clearly, when we create something like an OpenGL context, we're going to need some kind of handle to the window so that we can actually control things, right? Basically, we're going to just take in a GLFW window handle, and I'm actually going to do this from the constructor, okay? So the constructor is just kind of going to, I'll just call this GLFW window. The constructor, or maybe we can just call this window handle for now. That way, if we change from GLFW, it'll still be a window handle. It's kind of makes sense. So basically what I'm saying, and what I might do is just make a forward declaration for GLFW window here, so that we don't have to include it. So basically, what we're going to do here is just set that property and window handle, right? That's what we're going to do in the constructor, which also means that we need to go into Windows window over here. I'll include our context, renderer graphics context, Hazel. Do that there. This thing I'll include in OpenGL context.cpp. I don't know why it's not toggling between header file and CPP file, but anyway. So we've got the constructor, we've got init. This is OpenGL context. We can remove the pure virtual stuff and add that it's an override. And then from our actual window, we've got so much stuff open that we don't need. From our actual window, that's where we're actually going to set our window, so m window. And obviously we're going to do that after we actually create the window. So we'll create the context, and then we'll initialize that context. Okay, so OpenGL context, it's not happy with that. So we've got our graphics context, and then over here, we will use Hazel, or platform, where is it? It's just platform, is it? Yeah. Platform, OpenGL context. All right, cool. That should make most things go away here, all the errors. Yep, cool. All right, and that's pretty much it. So we have the window, and now we can kind of do everything we need. And that looks pretty good to me. So we'll grab this line of code, and we'll go into init, which I guess we haven't created yet. And we will just put that in there. So let's actually make all of this stuff. Yeah, it really doesn't think that, have I? Oh, of course, I misspelt it. Well, that's why. Context. I wonder how long you guys were watching that for before you realized how stupid I was. You're probably yelling at your screens, being like, what are you doing, Cherno? Okay, create method implementations, and then obviously here, the only thing we're really going to do is window handle, Opengl context. Init's gonna do that. This is the window handle. And then the glad, we also need glad. So one of the things we've done here is we've removed Opengl dependencies, right? So glad is not glad is Opengl specific. GLFW isn't, but glad is. So that's another thing that we've kind of taken and are now removed from window. So there's nothing really that ties it specifically to Opengl anymore, because this stuff kind of happens here, which is really cool. And then we'll also go into Windows window and then take that swap buffers code that we had and actually move it into here, into swap buffers. All right, really easy. And then window handle is obviously what we have over here. And we could do things like assert to make sure that that window handle actually exists. So, you know, window handle is null. Window handle is null. We could do some basic checking if we wanted to, but I honestly think that this is really dead simple and we don't really need to add anything to make it super complicated. Okay, cool. Now there was something else I feel like I wanted to address, but I don't really remember. Okay, well this is an error. What actually is the structure of this? So inside source we do have platform, OpenGL, and then, yeah, not context. Okay, cool. Let's build everything, see if we get any errors or warnings or anything. And then we can run it and hopefully it'll work. Okay, so we do get warnings. Type no first name class sense struct. Yep, that's because, oh, and we even get, yeah, I probably misspelt something here. Context, maybe not. That's odd. Anyway, this should be struct. That'll solve that warning. And then what's this that's not found? Can't find something to do with that. Let's build again. Okay, we're fine. Maybe it was to do with the struct thing. Let's just run, see what we get. There you go. All right, cool. So we have this going on here. You know, we could do something like inside swap buffers. If we really wanted to test it out, we could maybe try, I don't know if this will work, no guarantees, but we could maybe try some immediate mode OpenGL, which, you know, I don't even know if it'll let us do that. Let's just, does that really not compile? Wow, it really doesn't compile. I don't know what we can do here. This stuff doesn't, that's really quite interesting, isn't it? This stuff just doesn't exist. What's in here? gl.h, which I thought I included, but apparently I didn't. I was gonna try and do some stuff. The other thing we could potentially do, I don't know if this will work though, is we could try and create a vertex buffer with some data and then see if we can render it automatically, but yeah, I kind of wished immediate mode would just work for us, but apparently it just doesn't. That's so interesting, isn't it? It just does not, we haven't even included it. That's probably a good thing. I mean, it probably wouldn't work anyway because we're using the core profile. But anyway, my point is that this should actually now be capable of rendering just like it was before. We don't really have anything to test with. I mean, you can see that the clear color is pink, so that's kind of promising. And if you're wondering, the clear color will be controlled by the actual renderer class, not by the context or anything like that. And in fact, to be a little bit more specific, this whole GL clear thing, which right now actually is happening inside application, this whole thing will technically be happening on a frame buffer. So we'll have like a rendering buffer, essentially a frame buffer that will just be our screen, right? And then that will contain things like clear commands, and that's going to be the architecture of that. Anyway, that is pretty much the context class. Really simple again for OpenGL, but now the big thing that we've achieved here is we're creating a rendering context, and it's completely, you know, independent here. I mean, we have OpenGL context. We should be able to just say, hey, I want a DirectX context just like that, and guess what? All it does is init. It takes in the window handle. All it does is init and swap buffers, right? That DirectX also needs both of those things. We can just have a different implementation and suddenly we have DirectX. And then obviously maybe in window props in the future, when we have multiple APIs, we would have something along the lines of like mdata, you know, .api or something equals props.api. And then based on that, we could maybe do like a switch or something and decide, or maybe even ahead of time, that instead of using OpenGL context, we would use a DirectX one or anything else. Hope you guys enjoyed that video. If you did, you can hit the like button. You can also help support the series by going over to patreon.com/the Cherno. Huge thank you, as always, to all the wonderful people that make this series possible. Next time, we're going to move on and start creating the renderer class, right? That's going to be something that's going to be probably designed and redesigned a billion times, but essentially we need that for things like the clear color, we need that for issuing rendering commands, right? We need that for state, we need that for so many things, and we might even have a bit of a design episode next time. I'm not really sure at this point. I still have a few things in my life that I need to sort out at this point in time because I'm making some changes. But yeah, essentially, next time I think we're going to start off with renderer, unless I kind of realize that something else is important that at this point in time I've forgotten about. But anyway, I hope you guys enjoyed this video. I hope you guys are as happy as I am to be back into Hazel and into this series. I will see you next time. Goodbye.